The formula for the volume of a cone is the same as that for the volume of a pyramid, which is to say V equals 1/3 of the area of the base times the height. Now in the case of a cone, the base is a circle, and the area of a circle is given by pi r squared, so the formula becomes 1/3 pi r squared h, where r is the radius of the base. So there's the centre of the circular base, and there then would be the radius. And the height of the cone is the distance from the centre of the circular base to the apex. That's the pointy part of the cone. So here's our first example. Volume equals 1/3 pi r squared h. Now the 8 is the diameter of the circular base. So you should know by now what to do to get the radius. Diameter divided by 2. So 8 over 2 is 4 meters. So 1/3 times pi times 4 squared times 9. Now, 3 divides into itself once and into 9 3 times. 4 squared is 16, and 3 times 16 is 48. So what we have here is 48 pi meters cubed. And we can now use a calculator. That gives us 150.796 meters cubed. Now what I'd like to do is to round the answer correct to 1 decimal place. Here is the first decimal place. So what happens to the 9 and 6? Well, the 9 and the 6 will round up, and the 7 will become an 8. So the answer correct to 1 decimal place is 150.8 meters cubed. Now this second example is slightly different from the first example. Working out the volume of a cone is very straightforward, but here we've got a slight problem. The 13 meters is not the height from the centre of the circular base to the apex. That's the length of the sloping edge of the cone. So we cannot use that in our formula. We can't replace h with 13. The question then is, how do we work out the height here? Well, I hope you can see that we have a right angled triangle here. And if we've got two sides of a right angled triangle and we want to work out the third side, then we can use Pythagoras. So, by Pythagoras, now it's going to be a smaller side that we're calculating, remember? This is the hypotenuse here, that's the longest side, the side opposite the 90-degree angle. So if we're working out a shorter side, we have to have a subtraction. Let's just call that h. So h squared equals 13 squared, take away 5 squared. Now 13 squared is 169, and 5 squared is 25, and if we subtract, we get 144, which is a square number, which means that when we take the square root, in this case we get the number 12, we get no decimals. So we can now proceed to find the volume of the cone. 1/3 pi r squared h pi times 5 squared times 12. Now I simplified the first example, I'm going to do that here as well. So 3 divides into itself once and into 12 4 times. 5 squared is 25. 25 times 4 is 100. So what we have here is 100 pi. 100 times 3.14 is 314. So it's possible to do this calculation without using a calculator. Example 3. Example 3 is different again. We're still working with the cone, so the formula is V equals 1/3 pi r squared h. But in this question, we're given the volume, we've got the base radius, and we're trying to work out the vertical height h. So, we've done this sort of thing before. Let's put in the numbers where they should go. So 565.5 goes in this position. The base radius is 6, so that's 6 squared times h. So let's get rid of the dividing 3 first. I'm going to multiply both sides by 3. So calculator, 565.5 times 3 gives us 1696.5. Now 6 squared is 36, so it's going to be 36 times pi times h. 36 pi h. What I want to do is to get h on its own, so I'm going to divide by the multiplying 36 pi. H equals 1696.5 over 36 times pi. It gives us 15 centimetres. In this example, we have a conical hole in a cube. So what we're going to do is to work out the volume of the cube first. And that's length times breadth times height. 6 times 6 times 6, or 6 cubed. Which is 216 centimetres cubed. And the cone, 1/3 pi r squared h. Now we can see, I hope from the diagram, that, well, the diameter of the base, circular base, is 4 centimetres. That means the radius is 2 centimetres, 4 divided by 2. And I hope you can see from the diagram, the cone seems to go all the way through, so the height of the cone is the same as the length of the side of the cube. So 1/3 pi times 2 squared times 6. Now, what can we do without a calculator? 1/3 of 6 is 2. Let me just do some of these calculations. So 3 goes into itself once and into 6 twice. 2 squared is 4, times 2 is 8, so I have 8 pi. Which gives us 25.13 centimetres cubed. So the volume that remains is 216 minus 25.13. And that gives us 190.87 centimetres cubed. Here's our final example. The word we use to describe this part of the cone which remains is frustum. It's a Latin word, and it simply means a piece or a bit, a remainder. So what we have here is, you can see that we have, or perhaps you can see that we have 2 cones. Here is the larger cone. And then we have a smaller cone on top, which has been chopped off. So we're going to do two volume calculations and then see how we use them. So volume 1 then, 1/3 pi r squared h. Now I'm going to work out the volume of the larger cone, so the radius of the base is 10 and the height of the larger cone is very clear, that's 50. So let's simplify if we can. 10 squared is 100, 100 times 50 is 5,000, so it's 5,000 pi over 3, and a calculator. That gives us 5235.98 centimetres cubed. Volume 2, the volume of the smaller cone. Now there's something missing from the diagram. That's this dimension here. The radius of the circular base of the smaller cone. I'm going to call that 5 centimetres. So that allows us to proceed. 1/3 pi times 5 squared. Well, the next problem is the height of the smaller cone, but that shouldn't be too difficult. We know that the total height is 50 and that this is 30, so 50 take away 30 means that this distance here, the height of the smaller cone, is 20 centimetres. Now, 5 squared is 25, times 2 is 50, times 10 is 500. So what we have here then is 500 pi over 3. And if we turn to our calculators, we get the answer 523.6 centimetres cubed. The very last thing we have to do is to work out the remaining volume, the volume of the frustum. So that's 523.98, 523.6. That's 471.2.4 centimetres cubed.